We will analyze now what the substation analysis provides us for insights at the example of one substation. I've chosen this substation here, which is close to Stavenhagen. EDIS is the operator, and we can craft the substation report. We can also, of course, have a look what kind of grid neutral battery storage makes sense here. Let's take the balanced approach. Let's take 50% of the time and 25% availability for charging, and let's see the result. So the result can be seen here. Yeah, in the first side, on the first page in the overview, you can see where exactly the substation is located. The name again, the report range. You can see if it's a generation alone substation or if also load is connected to it. What's very important for discussions for grid supportive BESS operation is if you are planning a battery storage there in the area, how would you operate it? So here, for example, to be grid supportive, based on the generation profile of the wind and PV plants nearby, but also based on the load consumption in this area, we recommend charging hours of like 9, 10, 11, 12, 15, 16, 17 o'clock, and discharge hours in the evenings here 18, 19, 20. We have some risky hours. This is because there are rapid net load fluctuations, so which can happen, especially if there is PV built around noon, because then it can happen that the battery is doing the opposite way and like maybe injecting energy when energy should be curtailed, or vice versa, or when the load is fluctuating strongly, or when the PV generation is rapidly going down. These are risky hours to consider, and this is why you can also see them in the restricted charge and discharge hours, because they play a role. And besides that, we also have restricted charge hours here at 7 p.m., which kind of makes often sense, because then a lot of people are coming home and there is a higher load consumption, and it would maybe not be advantageous if also the battery storage is loaded in that hour. Vice versa, if like the battery storage at 12 o'clock is injecting energy into the grid, it's not really helpful, because there is a lot of like PV production, which we can see here. There's quite some PV installed. Okay, we can see how many risky hours per year and restricted charge and restricted discharge hours are affected. We can see the total generation of wind and PV that is installed next to the substation, and which are connected indirectly or directly to the substation. Indirectly means through medium voltage bus bars. We can also see biomass generation. There is no biomass installed actually. And we see the total generation in kilowatt hours that is unconstrained. There's also happening some curtailment, wind curtailment, much less than PV curtailment actually. And the total curtailment is computed here. And we also see the delivered generation in kilowatt hours, the electrical load for different sectors like private industry, tertiary, and transportation sectors summed up here. What is very important are the load metrics. So we see how many hours per day we have an over generation. So we have like approximately 7.54 hours per day more generation than actual consumption. So this is good for charging batteries. Then we have a maximum net load. This is the maximum value when we form the difference between electrical load minus generation, and it's like the worst case supply deficit here. Yeah, so it means if we have like a positive value, the local generation is not sufficient to provide enough energy to the load there, and it has to come from the outer grid. We have a net load factor, which reflects how often the substation is in a net deficit state. So smaller than 0.5 is ideal for BESS installation. We have a minimum net load, so minimum load minus generation means like there is over generation at the substation, which is here peaking at 14.5 megawatt. So there is at a certain point in the last 12 months 14.5 megawatt injected into the grid, which are of course great charging opportunities for batteries to also help the grid not to need to absorb so much power. We give a metric about the generation load correlation between how often generation and a high load is coming together, because this is actually what the system operator wants. He wants a very high load generation correlation. So this is why if it's small, it's helpful to install batteries, because batteries can help to increase the correlation, and this is better for the grid and in the interest of a system operator. And then we also have a metric on energy curtailment, where you can see how much energy got curtailed and how much of it was actually in percentage of the total generation. In this case here, it's like 0.5% of total generation of the last 12 months. So a battery could definitely help to save here some energy. We also provide the timestamps and the wind generation, PV generation, and the curtailment in a table in 50-minute timestamps. You can easily do your own analysis with it. For example, you can have a look, okay, how much wind generation happens, how much PV generation. You can do your algorithms to see how you can overbuild a certain substation. If you have the expertise in your own team, I think this is the good basis here to include. And we also have like electrical loads included in 15-minute steps, what is actually consumed in this area. Last but not least, the BESS analysis, which gives an overview of our neutral, of a recommendation of a BESS that can be installed and that acts grid neutral in this area. So we have a recommended BESS power, which is like the battery power. We have a battery energy that is recommended, and we also based on the input parameters show, okay, how long the battery can discharge at full power, how long it can charge at full power in the last 12 months. We show the export cap at this substation based on different seasons, based on the hours. So we try to always stay within the defined limits. So this is like, for example, the export limit, which is the 80% percentile of the generation based on different seasons and based on weekdays and weekends, and plus a certain safety margin. But you can play around with that. If you want to have different export limits or a different safety margin, you can change this anytime. What you can also easily see is the curtailed energy at that substation by month and hour. You can see at what hours it's happening and in what months. As you can see here, it's happening in particular end of spring and also in the summer months. There is most curtailment in megawatt hours, and a little bit in the winter time, because there's also some wind power plants connected, but in comparison to summer, it's not much. What you can else see is the delivered energy per hour and per month, which shows clearly, okay, in what months and at what times there is a lot of energy generated and at what times there is not much energy generated. And it becomes also clear it's more during noon, because we have a lot of PV installed in this area, and this is why it's peaking here a lot. Thank you.